Right, so somebody today said, well, you came the farthest way here to come to the meeting, and I said, well, that's true, but I really, really wanted to come here because I like being with good friends like Dr. Greenbaum and Jerry and others that are here, and this is the best part of what I do is to be able to speak to lay audiences, so I really am happy you would invite me to come this way. And again, I'm going to try and be brief, but hopefully in the talk today, we'll stimulate some thoughts. And so the way I'm going to do this today is we're going to play a little game. And the game that we're going to call is work around the theme of Mythbusters. Mythbusters. Ooh. How many have heard of this TV show? Yes. All right, everybody. So the Discovery Channel is happy. So the way we're going to do this is we're going to revolve this theme around dogmas that we believe exist in type 1 diabetes. And we're going to handle it from this. And again, if you've watched the TV show, and now if you haven't, I'm going to bring you in gradually here. There's three things that happen in Mythbusters. Meaning you put out an idea, and there's three conclusions at the end. Either it's confirmed, or you hit a thing where it's plausible, meaning they're not quite so sure, but it may be. Or in the end, you have the infamous, yeah, oh, I got to get these Seattle crowds are tough, man. Okay, busted. Now, if you were at the Seahawks game tomorrow, I know you'd be a little more loud. Okay. All right, so busted. So, and in the way that this is, and again, Matthias and I are going to talk, is that if you know the show, they begin and they have a guy, and I wouldn't begin to try and draw anything because I can't draw much of anything, but they begin by setting up the cause and how we're going to explore this. The way they're going to explore this, and I took this from Dr. Hirsch today, I thought which was cool, meaning if you put something up, and this may be an age thing, but who knows who that is on the right? Jack Klugman. Yeah, Jack Klugman. Well, somebody says Quincy. Yeah, that's it. It's Quincy. It's not Jack Klugman. It's Quincy. Come on. And so it's a little bit of an unpopular subject, but what we set out to do with nPOD, with JDRF support, was a few years ago to try something new. Meaning that so much of medicine revolves around pathology, around looking at tissues to try and figure out what disease happens. And it'll affect everybody in the room, I almost guarantee, in your lifetime, where some lab test somewhere, it goes to a pathologist. If you have a biopsy, it goes to a pathologist. And for whatever reason, years ago, in fact, decades ago, we kind of succumbed to not doing much in terms of pathology in terms of type 1 diabetes. Most of it stopped in actually the 1970s and after some work in the 1960s. So thanks to some vision of two things. One, the late Dr. George Eisenbarth, if you've heard of him, he kind of had an idea that we need to go back to studying tissues from individuals with type 1 diabetes. And number two, the JDRF. Dr. Eisenbarth took to NIH the notion of trying to study pancreases of individuals with type 1 diabetes, and they said, no, it can't be done. And we have mice. And so we're not going to be interested in doing this. And so George came to me and my colleagues and said, can you get this to happen? And JDRF had the vision and took a step of faith. And so what nPOD is, it's an operation that works 24/7, 365. We work with every organ procurement organization in the United States. And about 400 times a year, I or my colleagues get a call, usually during the middle of the night, where somebody has given a gracious gift where they are giving organs from their loved one, either with type 1 diabetes or some other situation for research discovery, often in terms of transplant. Many people with transplant have pancreas, many people with type 1 diabetes have transplants, et cetera. But our goal as nPOD as an organization to use these tissues in a collaborative way to try and find out the issues to the questions of what causes type 1 diabetes so that we can develop a cure for the disease. It's been an exploding phenomenon. When we started, people didn't think that there would be interest in studying human tissues. We started with 6 projects 7 years ago. Now we're up to 148 projects around the world in 17 countries. And nPOD's also very unique in that, unlike a lot of research where it's very siloed, meaning one investigator studying tissues or a team, nPOD's unique in terms of taking the data back from individuals and then sharing it. It's a real unique thing. And the nice thing about this is it has the capacity to revolutionize our thoughts about type 1 diabetes, and that's why the Mythbusters analogy. So I'm going to start with this one here. Now I'm going to, again, make this interactive. How many have been told this notion when you were either diagnosed or you read it somewhere along the line, that type 1 diabetes develops when about 90% of your beta cells are destroyed? Has anybody heard something like that? Okay. Yeah, there's a good number of hands, not many, but I'm going to say busted. I didn't ask you to guess. I'll start pulling some of these in, but the reality is there is a notion of this, and part of the reason is that there's this figure that's in many textbooks that people talk about and use over and over again that suggests that when the notion of about 90% are gone, that's what happens. And there were actually studies done back in 1965 that if you just look at the numbers and some quick math here, if you compare the pancreas of individuals with type 1 diabetes and they had this many islets versus about this number in controls, people said it was 90%. But what we're learning from nPOD and others is that it's a very different situation. In that in reality, we think that it's about, on average, it's about 70% of the islet cells may be destroyed or very sick in terms of type 1 diabetes, but it's very different depending on the number of variables, the age of individual. So it's about 50 to 90%. It's not 90%. And this is really important for investigations that TrialNet, Dr. Greenbaum, and others are doing where they're trying to reverse type 1 diabetes, because there may be much more hope for reversing the disease than what was once thought. So this is the part of an example of a myth buster that we need to get out, and is coming from the studies of human tissues. Myth number 2, type 1 diabetes is an autoimmune disease that occurs by the exclusive loss of the beta cells by the blood cells, the white blood cells of the immune system. And again, we've seen this today, and I'm not poking fun at people because it's there and it's a thought. So is there any quick guess at what this is going to be? Oh, I wish it were busted, but it's not. It's plausible, meaning when people spoke about this today, it is true. If you look at the pancreas of individuals with type 1 diabetes, and again, this goes back to studies in the 60s, we know, and actually the first description of this dates back to 1910, and I happened to go to England last year and look at hand drawings of individuals who they didn't do photography, but they drew it. And again, there is this white blood cell infiltrate, so clearly type 1 diabetes is an autoimmune disease. But one of the things that we're learning by studying these pancreas is that autoimmunity is in a way a homicide of the beta cells, meaning that the immune system goes in and is actively destroying the cells. But there's we found at least 2 other factors that may dramatically contribute to this. Number 1 is there probably is a situation what we call a suicide of the beta cells. And I'm not the inventor of this. This was a notion actually put forward in the 80s by an investigator in England. But it seems like there's some reason the beta cells may contribute to their own demise. And if in question and answer time you want to talk about some of this, we can talk about it. But the beta cells in individuals with type 1 diabetes appear very unique. And they're contributing to their own demise, even beyond, above and beyond what's going on with the immune system. And the second thing, and this is a real growing interest of mine, is this whole issue of a small pancreas. And how many people in the room heard that the pancreas of an individual with type 1 diabetes is smaller? Like nobody. But the reality is, and this has been fascinating, and we published this study in this journal. Dr. Palmer talked about high-impact journals. We published this in a high-impact journal about 2 years ago. Was through nPOD. We took a look at the pancreases of individuals who didn't have diabetes, and this is a weight. And then we took a look at people who are at risk for type 1 diabetes, and then people who had type 1 diabetes. And what was fascinating to us is the pancreas of somebody with type 1 diabetes is 46% smaller than a similar age or BMI match control. 46%, almost half the size. And there's been a lot of studies, including those coming out of the Benaroya Institute here in town, that have taken a look at this organ, and there's many other people, because this is nPOD and it's collaborative, that are taking a look at some of the reasons why the pancreas is smaller in individuals with type 1 diabetes, and or why the pancreas might induce autoimmunity. And Dr. Von Heerath, our next speaker, has been working on some of this, and he's going to present some of this data in his talk. So I just want to say to you is that it's true, it's plausible. Type 1 diabetes is autoimmunity with the white blood cell, but there are other factors that are involved in this. And if we really want to extrapolate this, and this is what we call a hypothetical model, which means a lucky guess or an educated guess. And I don't know if it's true, so don't leave here saying it's true. But what we're wondering now, and we're testing is we've always thought that individuals might be born with who are going to develop type 1 diabetes might be born or shortly after birth have 100% beta cell mass. Well, now part of nPOD is dedicated to questioning what that level of normal is. Because it could, in adults, we now know that there's a lot of, there's a difference in the number of beta cells that an adult with type 1 without type 1 diabetes has. And we're wondering if that exists in children too. And it could be that the number of beta cells that you have shortly after birth determines whether or not you're going to develop diabetes. So we'll see. Myth number 3, type 1 diabetes is type 1 diabetes. Any guesses? I just need one. Okay, yeah, I don't know what you said, but I'll take it. Busted. And that reality is we're here as a type 1 diabetes nation today, and a lot of what we're going to hear about is we're talking about type 1 diabetes, and whether you have the disease or your family member, we're speaking of it as if it's all one disease. And one of the other things that we're learning from nPOD, actually, and I'm not saying Dr. Palmer's old, but for people that have been working with type 1 patients for a long time, there's always been this notion that no two patients are alike, and that's not quite right, but that's just the phrase, meaning that it's hard to understand why some people that work so hard to manage their diabetes, but yet their A1Cs look pretty good, then there's other people who don't take good care of their diabetes, but their A1Cs will be good. How do you validate or handle situations where there's such differences? And one of the things we're finding out from studying the pancreas and the genetics and other factors in type 1 diabetes is there's great heterogeneity in the disease. And that as we look at tissues from these individuals, we're starting to get the first grasp of understanding what might be going on in an individual that, say, develops type 1 diabetes at the age of 5 versus 15 versus 35 versus 60. And that one of the things I think we're learning from nPOD is that type 1 diabetes, or there's a suggestion, that's why I put it up there, that it's a heterogeneous disease. Commonality, people need to take insulin, it's insulin requiring. But one of the wise things we need to do moving forward, I believe, and others may agree or disagree, is we need to understand that there's great heterogeneity to this disease. Okay, we're about halfway done, but here's another one that always gets out there. So how many people have heard within a few months to symptomatic onset, meaning after you do or do not have a honeymoon, that you'll be no more beta cells in your pancreas? Has anybody heard that? Yep, I heard a few of that. Well, guess busted, yes, all right, thank you. So that went by quick. See, we didn't need to do this because everybody came out. And the reality is this has been one of the most profound studies that come out to nPOD, that we've been partnering with this group at the Joslin Diabetes Center with George Keene, who has what's called a medalist study. So this was set up by Elliot Joslin, where they tried to get individuals who had type 1 diabetes for 50 or more years, which at one time, if you lived that long, that was a great accomplishment. Now we pretty much believe almost everybody has that potential with the way the diabetes is managed now. But when it started, that was a real Olympic-like event, and people would get, actually, to this day, if you have diabetes 50 years there, you get a medal. But one of the things we did was we recovered 12 cases from individuals who had type 1 diabetes 50 or more years, and we're pretty shocked when we found that 11 of those 12 cases, we could still find insulin-producing cells in the pancreas. All of that time, breaking down this dogma. And I want to go back to another thing that Dr. Palmer talked about when he was talking about the DCCT and EDIC study. And this might sound like a little bit of waving a hand, but there was this old dogma that, again, not just where it's rare that you can actually look at the pancreas of an individual, but we have the ability to measure this, C-peptide that he presented in serum. And so old school thought, if you would, is that within, after a few years of type 1 diabetes, in this case 5 years, it was really only a small percentage of individuals out here have the ability to produce C-peptide over a long period of time. Now, this might be a little bit of a hand waving, but newer assays that are out there, by assays I mean laboratory tests, that are much, much, much more sensitive in their ability to detect C-peptide suggest a very different picture. The reality is that by far and away, a majority of people, long time after diabetes onset, have the ability to produce C-peptide. Now, I don't want to overemphasize this and everybody leaves saying, oh, I've got C-peptide and insulin producing. This is really, really small amounts, and it's certainly not enough to overcome the need for exogenous insulin therapy. But it does break apart this dogma that's just told by many that your pancreas within months of disease has no more beta cells. So this is, again, offers hope for explanation or for exploration on how to improve on the situation. And many people, including the trial net efforts that Dr. Greenbaum over here overseas is trying to work on this. Myth number 5, the incidence of type 1 diabetes is increasing, and it's mostly in obese teenagers. Yeah, okay, you got that one, good. Now, this is it, and I think everybody here, they look at the mall or the people in McDonald's or the kids with their pants around their, their butts or whatever, and then they look and say, that's the reason they're going. But the reality, and when the United States has tried to take a look at what's going on in diabetes, it's actually, we got into the game late, meaning that back in the global incidence of type 1 diabetes is increasing, and don't hear me wrong about this. And in Scandinavia, this has probably been explored the best, and I didn't put the one figure in here, but actually back in 1950 in Finland, there was about 10 cases per 100,000 individuals per year, and now it's around 60. So there's been this dramatic increase, and it's actually occurring all over the world. Now in the United States, back in the early 2000s, they formed this effort called the SEARCH study, and again, Dr. Greenbaum and Ben Roy and individuals here are actively involved in this, but it took a look at thousands of individuals under the age of 20 that are diagnosed with diabetes. And it's been looking at what the features of them are both at one given point in time and then over time. And earlier this year, they published this study that showed that actually it is true that in the United States, if you look at older individuals, adolescents, and compare the incidence rates of type 1 diabetes in 2001 versus 2009, it has increased. Interestingly, in this study, though the only age group that didn't have a major increase was in the very young. And this, meaning between the ages of 0 and 4. And this was very intriguing because for the previous 3 or 4 years, almost everybody had been saying this was occurring because it was data from Finland that where I showed you that diabetes was increasing. In Finland, if you say, well, what age group is it increasing the most? It's actually in that very young group of age 1 to 4. So this kind of piles on to the other issue I mentioned when I said it's a heterogeneous disease, meaning we're falling into this trap where we believe that type 1 diabetes in Washington is the same as it might be in Florida, and it's the same as in Finland or Sweden and China and Australia. It appears, at least in these big epidemiology studies, that it's increasing in different age populations, and there's a lot that we could speculate on what this means. But given the obesity and the rates and the healthiness, it does, and it's not necessarily that it's increasing in obese teenagers, although a lot of people are told that. Oh, that went quick. So this is like knowing the answers before the exam. But type 1 diabetes is caused by an inciting event, likely a viral infection, and I didn't have to have hands on that because almost everybody's told that, and I say that that's plausible. But when I say it's plausible, we don't know what it is. And meaning if you've had type 1 diabetes and been following this for years, I pity you because I pity myself, and that every 2-3 years we hear about something that's been found as the cause of diabetes. It's a virus. It's whether you breastfed. It was, did you give your child infant formula before 4 months of age or after 6 months of age? Did you cesarean deliver or vaginal deliver? The NutraSweet, oh my, did you get a childhood vaccine? I mean, we've had almost everything put out there. And the reality is that every one of these, where we are now, and this is a little bit from nPOD because we do some of these studies, but also from the TrialNet and TEDdy studies. The reality is we just don't know what in the environment causes type 1 diabetes. A couple of us were at a big conference in Europe 2 months ago, and group after group after group got up and said, well, they thought it was one of these, and the other group would say, well, we looked at that, and it's not this, but it's the other thing. This is a big problem in type 1 diabetes, but fortunately, it's not all bad news. Again, our first two speakers, Bill Hagopian and Oka Lernmark, with their notions of and their activities with the TEDdy study, I really and sincerely believe they're going to find the answer to this situation in terms of identifying environmental constituents. My hunch is that going to be many different things, and it's also not just going to be a trigger like one thing. It's going to be a combination of these, and it'll be different for different people, and it's going to be over a lifetime that it's involved. Just two more, if you can bear with me, is that in this one, my hosts who've been very gracious, JDRF this morning, I had a chance to speak to people last night, and everybody was asking about stem cells. So I did a little tweak this morning. So stem cells are just about there in terms of cure for diabetes. Who's heard this one? A bunch. So, plausible. And the reason is I only need to go back 4 weeks ago, and which was probably the latest round in this. So you have the news cycles. What do they say? It's a 24-hour news cycle, although sometimes they go much longer, like this one, which hit the blogosphere. So you have the news cycles that go that, oh, this is the cause of diabetes, and then you have this intermediately broke up with this is a cure for diabetes. So we went through this one. And I mean, look at this. Look at these titles. Cure for type 1 diabetes, imminent. Imminent after Harvard cell breakthrough. And then there was somebody brought me the London Times had this article that said, finally the cure for diabetes found. I mean, big bold headlines, front page. And the blogosphere, if you're in the blog, I don't have a web page, so I'm not so cool, but if you're in the blog, but my email was lining up. And you just see all of this articles. And what bothered me was I was getting some emails from people where they were giving these quotes where people were saying, well, this is the greatest breakthrough in diabetes research since the discovery of insulin. And I just want to say that, if you've been in type 1 diabetes, this is a long slog, and it's a productive slog. I really believe this is it has the potential to be beneficial one day, but we're not there yet. And it was so interesting I've been a type 1 diabetes investigator for 30 years. I've never had this happen in 30 years, never had it. That the journal that published that one article, Cell, contacted me about 2 weeks ago and said, there's been such a public outcry about the stem cell and its therapeutic implications. Would you write an article on this? You have 4 days, and we're going to publish it in 10 days. That just never happens. So we put this out there. I contacted a couple of people that know this, some of the area know it along with me, and we put this together, and it just came out 2 days ago. And the thing is what we call this is that the stem cell therapies we're hearing are 2 steps forward, but we need to take a time to pause because the stem cell therapy field is a little bit difficult in terms of the amount of promise that they're giving. There aren't any standards, and the motion of translation names them clear. So in the last, I'm going to skip this one, and okay, I won't. I heard O. No means to prevent or cure type 1 diabetes exists. And I put as plausible. The reason is, and this was my one great humor today, that might not be so funny, if you're mice, we got you covered. And that, this is something I did a while ago, and 20 years ago I did, there were about 100 cures. 10 years ago I did about 200. This spring we retested, and there are over 500 cures for diabetes in mice. In humans, there are none. But as you heard from from Dr. Greenbaum and others, we're really working to change that. And the last myth, and I'm sorry, is that, and this is the most important slide you'll see today, is that a lot of people have been told that if you have type 1 diabetes, it's just given you're going to get retinopathy, nephropathy, one of the complications of disease, and this is busted. And Dr. Hirsch alluded to this in a little bit, Dr. Palmer, and this is all diabetes, but if you don't think we're making progress, you're missing the point here. Is that this article came out in the New England Journal of Medicine, again, high impact journal, early this spring, late this spring, that showed that if you look over the last a few decades, dramatic decreases in kidney disease, eye disease, cardiovascular disease, and diabetes. And so we are making progress. So if you hear that thing that, oh, you're going to get disease complications or you're going to have Rocco, that's busted. That there's great hope, now more hope than ever. It's the best time we've ever had in type 1 diabetes research. And I'm sorry if you have type 1 diabetes, but if you have to have it, it's the best time ever to have it. So anyway, so thank you very much.